I/O signals definitions, types, and wiring. Today we will discuss the connection between the I/O card and the field instrument, and also how to identify your input outputs and identify your cards. Your PLC or DCS has two types of input outputs. One of them is a hardware coming from the field, and one of them is called soft link or soft I/O, which comes from HMI, PLC, or DCS. Today we will talk only about the hard I/O. So what is our mission today? First is to identify the input output and identify the cards. Identify the input output comes from the knowing which type you are talking about and the power supply and the required power for each one of those I/O. Then we put them into a list, and from this list we will group them based on the rules and the instruction we have. Then we can assign the card. Of course, we have to find the card which match those groups. Each one match one group, and then we can assign cards to a group, and then we assign channel in the cards. These are the most common I/O you will find. The analog input and output, mainly 420 milliamps, which are the current, but also there is 1 to 5 volt and so on. We will see now. Digital, we have digital input output, and then temperature, which is thermocouples or RTDs. There is other type of input output, which could be a high speed pulses, encoder, and so on. When we talk about the power supply required for each one of those input outputs, it could be AC or DC. The power can come from the PLC card or from the PLC panel from a power supply in this panel, or even can be comes from the field. What is the sources of your input output? So this I/O can come from the field when we measuring temperature, pressure, flow level. If we control a valve to open, close it. If we have a switches, give us a high pressure, high temperature, low pressure, low temperature, low level. So it switches. All of these come from the field. Panels can give us some statuses and alarms. Power supply failure, network switch failure, door is open, high temperature in a panel. If you have a compressor or any equipment, you can start it, stop the compressor. You can have some statuses, or you can have some alarms from this equipment. MCCs, we can control pumps through starting and stopping, or valve we can open or close by controlling circuit breakers. On the same time, you can receive from the MCC statuses, motor is running, motor is stopped, alarms, and so on. UPS, normally you receive some statuses about the UPS conditions, batteries condition. HVAC, you can read the status of the HVAC, but also you can close some dampers or start some of the fans and so on. Same as fire and gas, SIS, we can send and receive also I/Os. What documents you need to figure out what is your I/O? In the field, you need P&IDs, and you need the vendor catalog and datasheet for each one of the input-output devices. Panels and equipment, normally you need the wiring and the schematic for each one of the inputs and the outputs. If you're talking about the MCCs and the powerhouse, sometimes you need the single line diagram because you expect some data coming from the different circuit breakers and so on. Now we have something, we said we have some rules when we put our I/O into groups. Some of these rules dictated by the projects or the process, or we can dictate it ourselves. For instance, if you have two pumps running, one running and one is backup, you may say, I'm not going to put all the signals from the two pumps on one card. So if you have a failed card, you lose all your signals for both pumps. If you have train 1, train 2, or a similar situation, you may segregate the input output. Sometimes you segregate the loops per loop or a reactor types or some. If you have some instrument in the field which far away and you can install remote I/O, you may say I'm going to use remote I/O for those group of input output. Why remote I/O? That will reduce the amount of cables between the signals devices and the PLC or your DCS. So you need your P&ID, you need the layout, and then the I/O list, and you got the know what I/O will be in the remote cabinet or some will be in your marshalling cabinet. Some of the project they said we need 10% spare channels for each type, minimum one card. So are you going to distribute the spare channels on all of your cards, or you can combine them and put one empty card? Again, you can put there is preference for each project, preference for each client, and also you can have your input as well. So let's now look at a typical P&ID. You have a tank with a level instrument, level indication. That means you have 420 milliamps coming from this device, which looks like it is a radar. Maybe it needs power supply. This is LIT, looks like it is a differential pressure transmitter. So I would expect I have 420 milliamps from this one as well. Also from the pressure transmitter. From flow transmitter, I have two signal 420 milliamps because this is both are dotted lines. Now I have from the FIC, I have 420 milliamps analog output. But what about the pump? What about the valve MOV, the motor operated valve? Each one of them, they have a lot of IOs. So they give them a separate P&ID for each one of this equipment. So this is a typical MOV, maybe 1, 2, 3 types. So each one will have its own typicals. So in this, you can see we have 3 digital output, open command, close command, stop command. That means when you send the open command as a pulse, the valve will start to open until it 100% open. But if receive something in between while it's still traveling as a stop signal, it will cease at that moment. So you can open the valve with 20%, 25, 50%, whatever it is. There is other type, you can give it one signal to open, and if this signal stopped, the valve will cease at this moment. Or some other types which you give it a pulse and it will go from fully open to fully closed. The feedback from the valve could be digital, could be analog. Here I put it as a digital. Valve fully open, valve fully closed, local remote in a local or remote, and I have an alarm input as well. So in the MOV local panel, you can find some indication lamps, some push buttons, some selector switches. So each type has a different type and numbers of IOs. Pump. You may have for the pump a local panel in the field. Beside the pump, you can start stop it. You can have two indication lamps, one for run, one for stop. Now, in the MCCs, you can have also a different start stop on the MCC. You may not have it. So in the PLC HMI or the DCS HMI, you can have a start stop. You can have some indication. So in this case, I have two DOs, four DIs. Digital input can come from a float, level transmitter, pressure transmitter, push buttons, selector switch, or even a relay contact. Here we have in Automation Direct, you can see how they connected to a PLC card. It is a DI isolated AC digital input. Now this is another card, is a DC digital input, and it is so each 8 signals has a common with them. So channel 1, channel 2, or device 1, device 2, or DI1, DI2. So this is, you can see here, this is my field contact, and here is my power supply. I can have the plus go to my signal coming onto the input. In this case, we call it sourcing. This is a different type of digital input. It's called three-wire switch, which is proximity switch. Some of the control valve now, instead of having limit switches, we use proximity switches. Digital outputs. Here we can see a digital output cards. There is two types of cards. One of them is a transistor like an SCR or TRIAC, and the other one is a relay based digital card. This is a big difference between both of them. The relay can give you a dry contact. The cards with this transistor or SCR or TRIAC will give you a voltage. The transistor types, they can put a lot of them into a card, but most of the problem would be that they have a very small current through them. So I use them and use interposing relay to use a different high load for my output. Now, if you look at your digital output card, it will go into the interposing relay coil. Why you need an interposing relay? If your card has a DC output, your load need AC, so it's a different voltage type or level. This is 12 volt or 24 volt, and this is 48 DC also, or AC and DC, or you need a high current load. You can get it from your card, or you can have the channel is powered by the other system, which is a typical thing in the MCC. So you have in the MCC a motor controlled circuit, which is probably 220 or 110. So what is expected from your PLC is a dry contact. In this case, you need an interposing relay. The problem you will face is where my interposing relay will be. Is it will be in my PLC cabinet or it will be in the MCC. That means those two wires will go all the way from your PLC to the MCC, or those two wires come from the MCC to your cabinet. The other reason to use an interposing relay is to isolate your load and field wiring and problems from my PLC or my DCS. If you look at your solenoid, each solenoid has voltage and current expectation to start to hold and maintain its position as on or off. You can see here this is runs on 12 volt and it takes 11 watts. Now when you have a card with a relay output, most of the time it will be one contact normally open. So if your channel is active, then this will be closed. If it is deactivated, this will be open. Some of the cards can provide you with normally open, normally closed. Analog inputs. 90% you will find 4 to 20 milliamps. So when you look at the I/O card, look at the resolution, look at the wire cut detection. So it can tell you if the wire has been cut, you lost the transmitter completely. Can it see the over and under voltage, the signal detection, where the power supply comes from, and if it is redundant or not. So because we're talking about the I/O, here is a little bit of about the 420 milliamps. This is a two-wire transmitter, low power. That means the transmitter and the signal comes on the same two wires, and the power comes from the PLC cabinet or the PLC card itself. A different type is the four-wire transmitter, which can act as a two-wire transmitter or can act as four-wire transmitter, and it will supply the power to your signal. Thermocouples, we all know that thermocouples is two different wires which are combined together, and if you expose this joint to heat or temperature, then if you measure on the other two sides, you can see there is a potential or a voltage there, a millivolt. Based on the two types of the wires, we have different types of thermocouples. So we have J, E, K, R, S, T, and so on. Each one has a separate range you can use or a specific range recommended to use. How you connect a thermocouples? This is automation direct card, which you have the two wires from the thermocouples goes to your card. Most of the time, the card actually can accept any one of those. The signal is not linear, so there is a curve fitting inside the card. So all you have to do is tell the card which type of thermocouple I connected to you. RTD is mainly a small wire of platinum, and this wire, the resistance of the wire depends on the temperature. Here you can see this card is 100, 200, 500, or a different type of RTDs. So again, we can see here a simplified circuit for 2-wire, 3-wire, and 4-wire RTDs for the same card. So please look at your card specification and see if it is accepts 2 and 3 and 4-wire RTDs. If you have in the field RTDs, I recommend to go at least with the 3-wire RTDs. Now we have two options. If you have thermocouples or RTDs, we have two options. The first one is to connect your TC thermocouple or RTD to the card directly. So all you have to do is to look at what type of thermocouples and buy the card and select the card which is matching your RTD or your thermocouples. The problem if you have one or two or three, right? Then you'll have one card for one thermocouple. But the other problem is this wire. So for RTD you need 3-wire cables. For thermocouples you need a special cable for each type of thermocouples. The other option you can have is to mount a transmitter and field and then connect your thermocouples or RTD to your transmitter, and then you have 420 milliamps to your analog input, standard analog input card. A lot of people will go with this solution because it will give you easy, clean solution, and also you can have a standard twisted pair for each one of those transmitter. And on top of that, you can actually, if it is hard, you can reprogram it from the control room. So a lot of time we go with this solution, but in machines, you can also find that this is very cost-effective solution. So we use analog outputs to control a control valve opening. So you can go from 0 to 100%. You can control the speed of a motor or a pump between 0 to 100%. You can control a position of a sliding gate valve or a similar thing. So this is by a current 4 to 20 milliamps or voltage again 0 to 10, 1 to 5. It depends on your system. When your card specify 4 to 20, it will need a 24 volt to supply the power required for your load. In your PLC or DCS, you will find a lot of the cards, hard or non-hard. Like this is digital outputs in 8 channel, 16 channel, 32 channel, and so on. Here again, depend on the type of the PLC, not only the manufacturer, but also the series in those PLCs. So this is Automation Direct 400 series or 405 family. There is productivity. Delta V is different than Honeywell, different than Yokogawa, and so on. So please go into each one of those cards and look at exactly if it is isolated output, if it is not, what is the power supply, where the power supply comes from, and so on. What is the analog output, minimum and maximum resistance, digital output rating, and voltage, and so on. There is some other related videos in the playlist, which is the I/O list. We will see how we will put them now in Excel sheet, which is the I/O list, which you will give it to the DCS or the PLC vendor to go through them and start to see which type goes with which cards. At the end, thank you for watching, and please check the All About INC playlist, and a link is in the description. Thank you for sharing and leaving a comment. Thank you, and see you in the next video.